Hello students, in this video we are going to continue part 2 of our chapter Algebraic Expressions. First, we are going to start with simplified writing. We are going to learn how to write some algebraic expressions in a simpler form. If you have this expression a times b, this term we can write it by removing the times and it's equal to ab. If you have a plus a plus a plus a n terms, if you have a repeated n times, we can write it in the form n times a. For example, if you have 3 a's, we write 3 times a. If, for example, we have 5 a's, it means n equals 5, we write 5 times a. And also we can remove the times, and n times a, it's equal to na. So if we add the same term a number of times, we multiply the number of times by a, then we can write it na. Example, a plus a, it's equal to 2a. A plus a plus a, here we have 3 times a, it's equal to 3a. And it goes on. 5 times y, we can write it 5y's. 0 times x equals 0x. And when we multiply any number or any variable by 0, it's equal to 0. 1 times x is equal 1x. And when we multiply 1 by any number or any variable, it's equal here to the variable x. It's equal to x. So here x has an invisible 1. 1 is the coefficient of x. So here be careful. Negative 1 times x. Here the coefficient is negative 1 of the variable x. We can write it negative 1x or negative x. We can remove the coefficient in case it's 1. Now examples. 1, we have this algebraic expression. Here we have plus. It separates these two terms, these two monomials. Let's write each term, each monomial in a simpler form. It's equal to, we can remove the times, 4a exponent 5 plus 6b cubed. This is the simplest form possible of this expression. And if an algebraic expression has two monomials, we name it, we call it a binomial. A binomial is an algebraic expression containing two monomials. When we say monomial, it comes from mono. Mono, it means one term. Here we have two terms. It's a binomial. Example 2, we have this algebraic expression, minus 2 over 5 times m squared times m cubed plus 0.5 times m minus 9. Let's see how many terms we have in this expression. The terms are separated by the signs plus and minus. So here we have 1, 2, 3 terms. Let's write the simplified form of each term. Let's start with the first term. Of course, the coefficient cannot be simplified anymore. We copy it the same. Here the times, we can remove it. Now, if we have powers with same base, we can write them in the form of 1 power. M has exponent 1 and m cubed has as exponent 3. We can write it in the form m exponent 4. We add 1 plus 3, it's m exponent 4. So we write m exponent 4, and we can remove the times, and we copy n squared. Now the plus, we copy it. Here, the times, we can remove them. M and n different variables, so I cannot write them in the form of 1 power. So I write 0.5 mn. If you want, it's better to write the variables in alphabetical order. M comes before the n. In the end, I copy negative 9. If An algebraic expression contains three terms, three monomials, we call it a trinomial. So this algebraic expression has three monomials, it's called a trinomial. -9, the term that doesn't contain any variables, we call it constant term. The constant term doesn't have any variables in it. Example 3, x times y minus 3 plus x squared times 5y. Here also we have the signs minus and plus, so they separate three terms. So here we have three terms. First, let's start with the first term, x times y. We can write it in the form xy. We copy the minus 3 plus and x squared times 5y. To reduce it, first we write the coefficient 5. Then we write the variables in alphabetical order. X comes before y, so we write x squared y. Remark, we write the coefficient first, then the variables following their alphabetical order, as we did in both examples. Now let's continue with like terms. Definition: like terms may differ by their coefficients only. Example, we have these 8 monomials. Let's see among these 8 monomials which ones are like terms. To identify the like terms, we need to find monomials having different coefficient but same variables with same degree. For example, 5x cubed. Can we find another monomial having x as variable and whose degree is 3? Yes, we have -9x cubed. So 5x cubed and -9x cubed are two like terms. They have different coefficients, 5 and -9, but same variable x with same degree, 3. 0.3x squared and 9x squared are also like terms. They have same variable x with same degree, but different coefficients. So remark, like terms must have same variables with same degrees. So we found two other like terms. Now, 1/6 x exponent 4, and of course, x exponent 4. They are two like terms. They have different coefficients. The first has 1/6, and here we have 1, invisible 1. So 1/6 x exponent 4 and x exponent 4 are two like terms. 0.3 x exponent 5, of course, we cannot find a like term to it, so it's by itself. Also, 8 is a constant. We cannot find a like term. Example 2, we have these 8 other monomials. Let's try to find the like terms. Let's start with the first one. We have 3a cubed b squared. This is a monomial with two variables, a and b. The degree of a is 3 and the degree of b is 2. We need to find a like term who has also these two variables, a and b, with same degree. Here we have, for ab squared, no, the degree of a and b are, degree of a is different. Here we don't have c. Here the degrees are different. Also, here a cubed b squared, same variables with same degrees, but the coefficients are different, 3 and -9. We found two like terms. For a b squared, we have a of degree 1 and b of degree 2. Here, no. Degree of a is 1, not 2, so no. Here, 1/6 b squared a. Here the variables are not written in alphabetical order, so let's fix this problem. We obtain 1/6 ab squared. Remark, the variables of like terms might not be written in alphabetical order. Here, if we write them in alphabetical order, we notice that 4ab squared and 1/6 ab squared are two like terms. They have different coefficient 4 and 1 over 6, but same variables, a exponent 1, a exponent 1, b squared, b squared. Same degrees. Negative 0.4 c cubed a. Can we find a like term having c cubed and a? No, we cannot. So it's by itself. It's in fact negative 0.4 ac cubed. So no. 3a squared b. Here in these two monomials, we have three different variables. Here we have two only. So no, we cannot find a like term. C squared ba. The variables are not written in alphabetical order. Let's fix this problem. We obtain abc squared. 2abc squared, of course, they are like terms. The coefficient of abc squared is 1, and of 2abc squared, it's 2. So they are two like terms with different coefficient. Now let's continue with the final part of our video, numerical value of an algebraic expression. It's obtained by replacing each variable by given numbers and then performing the given operations. Example 1, we have this algebraic expression, and to calculate the value of this algebraic expression, we replace each variable by its value, then we perform the operations given. Question, evaluate a, it means calculate a. Solution, first we copy this expression with the given values of the variables. Now let's replace each variable by its value. Equals 6, we copy. A is 1, it's 1 squared, we write between parentheses. Here we don't have the times. Either we write 2 times 1 squared or 6 into 1 squared. C is 1.5. We write 1.5 between parentheses. 6 into 1 squared into 1.5. Minus 8 into 2 cubed into 1.5 squared. Now let's calculate by using the priority rule. Priority is 4 parentheses, so it's 6 times 1 squared is 1 times, and 1.5 we copy it, minus 8 we copy, 2 cubed is 8, so it's 8 times 8, and 1.5 squared is 2.5, it's 1.5 times 1.5 times 2.25. Now let's continue. Priority is 4 times before minus. 6 times 1 is 6 times 1.5, it's 9. Minus 8 times 8 is 64. 64 times 2.25, it's 144. In the end, here we have a positive number and a negative number. We subtract them and we put the sign of 144. We put minus. And we obtain negative 135. Example 2, b equals a minus b times a plus 2b, or we can read it a minus b into a plus 2b, where a equals 4 and b equals 3. Evaluate a. Solution, we copy the expression again, then we replace each variable by its given value. We replace a by 4 and b by 3. Equals, open the parentheses, 4 minus 3 into 4 plus 2b, it's 2 times b, it means 2 times 3. 2 times 3, we close the parentheses. Now we follow the priority rules. The priority is 4 parentheses. 4 minus 3, it's 1, into, here the priority is 4 times before addition. So be careful, we don't do 4 plus 2, we do 2 times 3, it's 6. We copy 4 plus, we follow same order, and 2 times 3, it's 6. Now we calculate what's between parentheses. It's equal to 1 into 4 plus 6, it's 10. And 1 into 10, it means 1 times 10. It's 1 times 10. We can skip this step and directly write the answer. 1 times 10 equals 10. And 10 is the numerical value of b. This is the end of this video. Thank you for watching.